Hi everybody. So this is the beginning of the videos. I'm going to try and talk you through it, just sort of explain what I've done and how I've got there. And again, if you feel free to ask, or you can feel free to ask questions in class. So here we go. I'm doing problem number 43 on page 90, and the problem reads 2 over y plus 4 over y is equal to 3. Now, I made two comments. One thing I could do right away is multiply everything by y. And what happens if you do that is you end up distributing your y, and then you end up multiplying this side by y. And so really what you end up with is y times 2 over y plus y times 4 over y, which is equal to 3y. And your y's will cancel in these two fractions, leaving you with 2 plus 4 is equal to 3y. Now I'll hop over here, and what that ends up giving us really is 6 is equal to 3y, and then you divide both sides by 3, and you'll get 2 equals y. Now you could have noticed immediately that you had a common denominator. If you have a common denominator, all you need to do is add the numerators. So you would have 6 over y is equal to 3. Now, you'll notice this y and this y get tacked on because I'm multiplying both sides by y again. And these y's will cancel, and so you have 6 is equal to 3y, and then you divide both sides by 3 and you get y is equal to 2. And one of the comments that needs to be made is you always check your domain of your functions. You can't plug 0 in here because we can't divide 0, but our answer is 2, so this is okay. All right, now we're going to slide to number 47, and it reads x plus 7, the quantity of x plus 7 multiplied by the quantity x minus 1 is equal to the quantity of x plus 1 squared. Now, what we're going to do for the x plus 1 squared is we can write it out as x plus 1 times x plus 1, and then we'll FOIL that, and we get x squared plus 2x plus 1. We'll FOIL over here, and we'll end up with x squared plus 6x minus 7. But if you check it, piece by piece, initially you'll have x times x is x squared, a negative x plus 7x, and then minus 7. And these two combine to give you a positive 6x. Subtracting the x squareds, we're left with 6x minus 7, and then 2x plus 1. And then we're going to subtract 2x. You get 4x minus 7 is equal to 1. We're going to add 7 and add 7, and so we have 4x equals 8, and x equals 2. And because these are both polynomials, and polynomials domains go everywhere, we are confident in that our answer will work. And we don't have to worry about a domain issue like we have up here where we can't plug in a 0. All right. We're looking at a similar problem, and I did a typo. I put plus, but it's actually minus. So we're going to FOIL here. We have x squared. Then we have minus 3x plus 2x minus 6. And then x plus 3 squared. You write it out. So it looks like this. X plus 3 times x plus 3. You'll FOIL that, you'll get x squared plus 6x plus 9. Subtracting our x squareds, they drop off, and then we're going to have negative x minus 6 is equal to 6x plus 9. We'll add x to both sides. I have minus 6 is equal to 7x plus 9, subtracting 9. And we have negative 15 over 7 is equal to 7. Negative 15 equals 7x, and then we're going to divide by our 7s. And so at this point in time, sorry for bumping that, folks, it really would just be looking like that, and then we're going to divide by 7, divide by 7, and then these cancel, and you're left with x is equal to negative 15 over 7. My comment is you can put the negative at the numerator, you can put the negative on the fraction bar, or you can put the negative in the denominator, and they all are the same value. Okay. Number 53, which reads x over x minus 2 plus 3 over 1 is equal to 2 over x minus 2. Now, when we're dealing with the denominator, I put a 1 under that whole number. And so we're going to work to get a common denominator. And the way that I work this, and I steal this from a former teacher that I worked with some time ago. And her phraseology, I think, is pretty good. So what does this denominator have? What does this denominator need that this one has? Well, it needs a 1. So we're going to write 1 times x minus 2. Now that's redundant. You don't really need to write the 1 there, but you'll see when we do our next one, it's helpful to have that wording in place. What does this one need that this one has? Well, it needs an x minus 2. It doesn't have the x minus 2 component. I can ask it as well over here. What does this one need that this one has? Well, it needs the x minus 2. And we observe the power of this entire expression like in the grouping, like I've grouped it here to the first power. Now, if you put it in the bottom, you got to put it in the top. And so x minus 2 over x minus 2 is really 1. So we're multiplying by 1. We're using that identity that we talked about in class the other day. And then what does this denominator need that this one has? It needs the 1. And again, we don't need to write the 1. Really what we would do is say, well, it's x over x minus 2 plus 3 times x minus 2 over x minus 2 is equal to 2 over x minus 2. Now, since they all have x minus 2's in the denominator, we can multiply through the entire equation by x minus 2's. And what we're doing here is we're distributing it to both sets of terms, and the denominators will end up canceling. And these denominators cancel, so we're left with x plus 3 times x minus 2 equals 2. We distributing the 3, we get 3x minus 6, and we'll travel up over here, and we have 4x minus 6 is equal to 2. Add 6, 4x equals 8, dividing by 4's, and we get x equals 2. And we have a problem here, because when we look back at the beginning, what happens when we plug in a 2 into this? Well, we're going to end up with 2 over 0. So even though we did all of our work right, we can't divide by a 0. And so this answer is actually not good. We're going to tell you that the answer is the empty set. Okay, I'm going to upload this video. It's the first couple set of problems. All right, you guys have a good one, and there'll be more videos to come.